The 21 senses are sight, smell, touch, taste, hear, direction, thirst, fatigue, hunger, itch, electromagnetism, pressure, chronoception, proprioception, equilibrioception, kinesthesia, nociception, stretch receptors, thermoreceptors, chemoreceptors, and mechanoreceptors. So those are 21 senses that we all have. We have mechanoreceptors, chemoreceptors, thermoreceptors, stretch receptors, lots of receptors. Nociceptors, kinesthesia, equilibrioception, proprioception, chronoception, pressure, electromagnetism, direction, thirst, fatigue, hunger, itch, smell, sight, taste, touch, and hear. Now I want to focus on, let's just start with the 5 basic senses, right? Eyes. You got sight, tongue, taste, nose, skin, and ear. When it comes to eyesight, here's some of the parts of the eyeball. You got rods and cones. You got the iris and the pupil and the sclera and the choroid and the cornea and the aqueous humor and the retina and the macula, the optic nerve, the ciliary body, the vitreous humor, the conjunctiva, lens, and the vitreous humor. Vitreous humor, conjunctiva, optic nerve, retina, macula, sclera, choroid, rods, cones, iris, pupil, cornea. Iris, pupil, cornea, cones and rods, aqueous and vitreous humor. What kind of humor you got? Vitreous. What kind of humor you got? Not more of the aqueous kind of humor. Conjunctiva, ciliary body, sight. Okay, so how does sight work? How do we see? How do we see things? The cones and the rods. We need cones so we could see color. Without cones, we wouldn't see the colors. And also central vision and details. You got to have your cones. So the first thing is we see through the eyeballs, right? It's a complex process. You got light. Light reflects off the object and then to the eye. So the light hits the object, goes to the eye. The transparent outer layer of the eye called the cornea bends the light that passes through the whole of the pupil. The iris, which is the colored part of the eye, I got a brown iris. It works like the shutter of a camera, retracting to shut out light or opening wider to let in more light. The cornea focuses most of the light. Then the light passes through the lens, which continues to focus the light, explained Mark Frommer, ophthalmologist at Lenox Hill Hospital in New York City. The lens of the eye then bends the light and focuses on the retina, which is full of nerve cells. These cells are shaped like rods and cones, are named for their shapes, according to the American Optometric Association. Cones translate lights into colors, central vision and details. The rods translate light into peripheral vision and motion. Rods also give humans vision when there's limited light available, like at night. The information translated from the light is sent as electrical impulses to the brain through the optic nerve. Once the cones and rods have been exposed to light, they translate the visual information into electric information. The optic nerve will send this information to your brain. The tiny nerve cells are able to take the electric form of the image in front of you and send it to the brain's visual cortex or the vision center. The visual cortex is located in the back part of your brain, the occipital cortex or lobe. The occipital lobe, it's responsible for decoding the electrical information coming from the retina. The vision center interprets the electric form of the vision, allowing you to form a visual map. Light bounces off the image in front of you and comes into your eyes through the cornea. The cornea is a clear, thin layer on the outside of your eyes. The cornea will help direct the light towards your pupil and iris. These two parts work together to control the amount of light entering your eye. The iris is the colored part of your eye, and the pupil is a little dark circle in the center of your eye. The sclera is the white part of your eyeball. The sclera, you may have noticed that sometimes your pupils are bigger and sometimes they're smaller. This is because an iris can shrink and grow, allowing different amounts of light to pass through your pupils. This is like controlling the aperture of a camera. Once the light comes through, the pupil will go through the eye's lens, Just like in a camera, the lens is used to focus on an object and direct the light to the back of the eye. The back of the eye is called the retina and has special sensors called cones and rods. Visual information excites the cone and rod sensors. Cones are involved in seeing color. A lot that goes in eyesight. There's a lot that goes in eyesight. There's a lot that goes in. Eyesight might be the most important of the senses, is it not? Of the 5 senses? I'm just sitting there thinking that there's 4 different kinds of, feel when it comes to touch. When it comes to touch, like just pressure, just friction, pain. Pain is different than itch. And then, hot is different than cold, and cold is different than pain, and then hot is different than itch, and itch is different than cold. And so there's, and then there's pressure, right? You could just put pressure. So there's different feel for, and then there's also equilibrioception. That's probably the most important one, or kinesthesia or equilibrioception. Equilibrioception has to do with the system, the vestibular system. So it has to do with your balance. Equilibrioception is your balance. Kinesthesia is your body in movement. Proprioception is your body in space. So all this stuff is important because we are gods. So why would we restrict ourselves to just 5 senses when we are able to have, a sense of time and a sense of our body in space and a sense of balance and a sense of our body in movement? So that's just some of the senses. 21 senses. That's what I'm going with for now. The more I think about it, the more I kind of think about it in different terms. But we have more than 5 senses, and I'm not going to limit myself. So different sensations may come to, it's all the same shit. Maybe itch and pain is the same thing. I don't know. But it's important to know that you have these different systems and these different sensations in how we interpret the world. Last thing I'll mention is the sense of direction. So a sense of direction, this is more of a mechanical thing. And I don't have a sense of direction. You wake up and you could see a thing, but you have to move in order to kind of see it from this side and see it from that side. You also have 2 eyes, so you have depth perception, but sometimes you have to close one eye in order to see the thing. Chronoception is a sense of time. Pressure comes from our ear. Electromagnetism, you could feel a magnet. You could feel the magnetism off a magnet. Electricity, what is that? What is that? We also have bioelectricity, electrolytes. But a sense of direction, if you were to wake up and you don't see anything, so let's say it's in the dark and you just see a light, you'll have to move around in order to kind of gauge how far that light is. Is that light right there in front of you, or is that light, is it a star and it's millions of miles away, millions and millions of miles away? So equilibrioception, your sense of balance. Kinesthesia, your body in motion. Proprioception, your body in space. That's just important shit to understand. So, you're not just your 5 senses. You're not just your ear and your nose and your tongue and your skin and your eyeball. You're an entire body. And you have, not just 5 ways to interpret the world. You got 21 ways to interpret the world. So, if I was, stranded on a deserted island, I would want to, let's go over my 21 senses. Let's make sure, everything's intact. Let's just check, like a pilot's checklist, right? Just make sure everything's working right. Just go over your 5 senses and then go over itch, hunger, fatigue, thirst, direction, electromagnetism, pressure, chronoception, proprioception, equilibrioception, kinesthesia, nociception, stretch receptors, thermoreceptions, chemoreceptors, and mechanoreceptors.